this, okay? And then, or a difference is where you have two perfect cubes and you subtract them. So those are the three different examples that we're gonna see in the lesson today. Now on the right, I always like to do some kind of Cornell Notes on the right. So I'm gonna just create a column over here just so I can separate notes if I need to. And just remember, everything we are doing this week is all about factoring. So everything is factoring. You're breaking down an expression into its smallest parts. Okay, and the goal behind that is to be able to describe a function later on when we start graphing and be able to understand more about it. When you factor it and break it down, it lets you see all those parts. But right now we're just kind of practicing the method. All right, so we're just practicing the method, learning how to do it, and then later on we'll be able to apply it a little bit more when we start getting to actual graphing and looking at patterns and those sort of things. Okay, so first example, I'm going to pull some kind of straight from this is the worksheet that's in the folder we're looking at. So you can see here that each of these numbers, these are all perfect squares. 9 is a perfect square because if I square root 9, I get a whole number, 3. If I square root 25, I get a whole number. Same thing with 16, 9. The only difference here is when I get to 20 and 125, those are not perfect cubes. Okay, so we got to go one step further in order to factor that out. Okay, so we're going to start with something like this. All right, so let's say I have 9m, let's just say minus 36. Okay, and by the way, I'll use highlighter. I have highlighters in here, guys, over there if you need them. Now, again, in order to do this, in order to factor this the way I'm going to show you, you have to have a minus. Okay, there's got to be a minus sign between the two terms. That's the important part here. Okay, as long as you have that, I can go straight to writing out the factors. Okay, so what I'm doing is I'm going to square root each term. Okay. So I take the square root of the first term, which is square root of 9 is 3. Square root of m squared is just m itself. And then I square root the second term, and square root of 36 is just 6. Now when I write these out, the first term goes first. So I literally just take that first term and write it in the first parentheses and in the second one. And I do the same thing with the second term. I write it right after that. Now the signs will always be the same in these cases when you do the difference of squares, and one will always be plus and the other minus. So you're always going to end up with plus and minus when you factor out a difference of two perfect squares. So again, in order to do this, go straight to this, you got to have a minus in the middle, and both the numbers need to be perfect squares. Okay. So here on the side, I'll kind of just make a note that when I do this, I'm going to do plus in one, minus in the other. And yes, it doesn't matter where the minus and the plus go. I could do minus first, plus next. It doesn't matter. Yeah.
So the 9m squared, whatever number it is, like the exponent, that determines how many parentheses you have. So if that was 9m to the fourth.
It doesn't necessarily determine how many factors you have. So each of these, each of these are a factor. Okay. So that doesn't necessarily always determine, but it could in some cases. When we look at the difference of cubes, we're still only going to have 2 different factors. We're not going to have 3. Okay, so you're saying, are you asking like, is that what? Is that why we have two of these?
Yeah.
Not necessarily, because even when we get to this one, when we have a 3, it's actually still two different parentheses. Okay. But like I said, in some cases, that does determine. Later on, we'll look at like some cases where that does, a lot of cases where that is the case. Okay. All right, so let's do another example that's very similar to that. So let's say I've got 18 minus, let's just say 50. And we'll say x squared. Now, what we do have in this example is we do have two terms. We do have a minus in the middle. Only issue here is that these are not perfect cubes. Sorry, perfect squares. So that's 18 is not a perfect square, neither is 50. So when I look at these problems, whether it's two terms or whether it's three terms, I want to look and see, okay, well, is there a common factor that I can take out of those terms before I actually start trying to go to the next step? So I want to look at the 18 and the 50 and say, okay, is there a common factor between those two? Is there a number I can divide into both? Well, in this case, I could divide 2. So there's a common factor of 2 between the two. All right, so now let's factor out the 2. So that means I'm going to divide it into these two terms. So that divided by 2 is 9, or 2 times 9 is 18. And then 2 times 25 is 50. All right, so the first step I'm looking for, in this case, a greatest common factor.
And the greatest common factor always goes on the outside?
Yeah, you always want to put it in the front, always on the outside of the parentheses. So that's why it's coming out of those terms. Now, if you guys look at these two numbers inside, those are now perfect squares. And it doesn't matter if that x squared, if the variable comes first or second, you can still do this. Because if you guys notice on this one, it was the first term, whereas here it's the second term. So it doesn't matter, you can still do this method. All right, so the first thing, I'm gonna go ahead and keep that 2 outside because it doesn't go anywhere. I still factor out 2, so it goes first. And I'm going to square root the first term. So square root 9, so that will give me 3 in both parentheses. And then I do the same thing to the second term. Square root 25x squared. Well, that's going to be 5x. And then I do the same thing plus minus. So again, that ends up being your first and last term. You just take the square root of those two numbers and then plug them in. First and last, and then you're always going to have plus minus, or again, you could do minus plus the other way around if you want to. Just know if you don't have a perfect square, you don't have a perfect cube, with these methods, you may have to factor something out first before you begin, okay?
And is there ever a case where you can't factor it?
Yeah, sometimes it's just not factorable. You might not. Like, for instance, good question. If I have, let's say, 4x plus 25. Okay, remember the requirement here is I've got to have a difference, not a sum. I can't be adding the two. So this is not factorable. This would not work. Okay, so with differences of cubes, if you start with two perfect cubes, now perfect cubes, let's just talk about what that means. A perfect cube means that if I can take one number and multiply it 3 times to get these numbers. So what number would I multiply 3 times to get 27?
Is that 3 times 3 times 3?
Right, 3 times 3 times 3. What number would I multiply 3 times to get 8?
2.
2. 2 times 2 times 2. So those are perfect cubes. Just in the same way that these are perfect squares, there's one number I can multiply 2 times, right? So 3 times 3, 5, or 5 times 5. Or in this case, 3 times 3, or 6 times 6. Okay, so now perfect cube. So you need a formula for this one, and the formula is, if it's a difference, which means you're going to subtract, actually, let me write it like this. If you have a perfect cube minus another perfect cube, the formula will be A minus B times, you take your A and you square it, and then you subtract A times B, and then you add B squared. All right, and I'll show you how to find the A here in a second. Okay, and if, let's say, in this case, it's a difference, so we're subtracting, but let's just say that it was plus, you're adding the two numbers instead. In that case, the answer is literally the exact same as this part. The only part that changes is the first part will be A plus B instead, and the second part will be A squared plus A times B. All right, so basically the first two signs just flip. So this sign and this sign will be the same. You can see that, oh, I apologize. That is supposed to be a plus. So the first one, it goes like this, minus, plus. And the second one goes plus and then minus.
And once we find our A and B, we can, in theory, plug this into Desmos, right?
Well, you're not going to plug it into Desmos because you're going to have a variable involved. So it's not going to, you're not looking for one number. You're actually just writing out an expression. All right, and I'll show you what I'm talking about. So the first thing, let's find the A. A is going to be equal to the cube root of that in the first number. So I take the 27 x cubed and not square root it, but I'm going to take the cube root. And I'll do the same thing with the second number. I'm going to take the cube root. That's why I write the little 3 right there on the top. Now, if you're not sure what a cube root is of the number, we already talked about it. Well, let's say you got like you're looking for the cube root of 216. All right, you might not know that off the top of your head. You might know that, so for a lot of us, we only know the first few perfect cubes because the numbers are so big when you start getting towards like 5 and 6. Okay, so I'll go to Desmos. Let's pull up Desmos. I like to use the scientific calculator. And what you need is this function right there. You got square root here, and then you have the root function where you can change that number in the top. So I'll put a 3 there, and then enter the number I'm trying to figure out. So let's say I'm trying to find the cube root of 27. It's 3. And then I want to know the cube root of 8. It's 8. Let's just say it was like 64. Then I know it's 4. Okay. All right. So just make sure that you're using this one with the little 3. All right. So the cube root of 27x squared, or sorry, cubed, is 3x, because I also have to cube root the x cubed part of it. And then the b would be 2. And now all I do is basically just plug those in. So now a minus b, so that means 3x minus 2. And then the next part, it says a squared. So what you're doing is you're taking that a and you're actually going to square it. So I'll kind of write this out kind of like step by step. I'm basically squaring 3x on the first part. And then I'm going to add a times b, so 3x times 2. And then I'll add the lastly b squared. So I'm basically just squaring 2. Now, you guys don't have to write it out like this every time. I'm just kind of showing you where these numbers come from on this step here. But here, nothing changes. It's just 3x minus 2. Now let's simplify the rest. So 3x squared, I squared the 3, it's 9, and the x, so it's x squared. So 9x squared. Then the next one is 3x times 2, which is 6x. And then the last one is 2 squared, which is 4. Now, the last part here, it may look like it's factorable, like I could factor this out, but you won't be able to. Okay, that last part of this perfect cube, like the 9x squared plus 6x, I can't plug that into the diameter of the box and factor that. It's just not going to work out. It's just the nature of this type of expression. You're just not going to be able to do anything with it. So basically, all you got to do with these ones is find the a and the b and plug it into the formula. Okay. And again, just be mindful if it's plus here, then you just change these two signs. Okay, any questions on those ones? Well, what if I get a perfect cube problem, but I don't have perfect cubes? Let's say, for instance, on this one down here. So there I have the cube. I know it's a perfect cube. It's a difference, or it's a sum of cube problem, because I see that little 3, the exponent, but 3 is not a perfect cube. And neither is 24. So that what that means is I probably need to factor out something first. So to think, what number could I factor out of 3 and 24? 3. So if I factor out 3, well, then this ends up being 3 times x cubed plus 8. And that first number in front of the x cubed is a 1, and 1 is a perfect cube, because I can do 1 times 1 times 1. It's still 1, right? So now my a in this case would be just x, or 1x, and then my b would be 2. And now I'm plugging that in. Now, when you start this one, anytime you factor something out like that, and I go through all the steps, make sure you put that in the front. That doesn't go anywhere. You want to keep that factor, right? So this, I would start off with like x plus 2, and then yada, 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 yada. Okay, then you finish that out. Okay, and by the way, that's number 14 from the homework that I'm showing you guys there. Okay.
Will you ever have to write x equals? And will you ever ask an answer like that?
The time that that I'll ask for, so somebody asked, when will I have to do x equals? The only time you'll have to do x equals if the problem starts with equals. So right now, if without an equal sign, this is just an expression. As soon as it's an equation, now I'm actually solving for something. So if I look back at the homework assignment from yesterday on the back page, well, the first part was just factoring, right? Just factor the expression. The second part, all of a sudden now it's equal to 0. Now we're actually solving for a solution. We're looking for the x-intercept, all the roots, whatever you want to call it, okay? The starting point. All right, that's when we start kind of taking it to the next step, right? Right now, we're just practicing the method, right? Then we start talking about how do we find the solution? All right, now we start bringing it back to the scenario, right? You guys remember like the rocket problems where like something's going up and it's coming down, and then you had to figure out the starting point and the ending point, and you had to come up with the equation. Okay, then we start going to that step. But right now, we're just kind of in a review, kind of getting the methods down, okay? All right, that is it for notes for today. I'll see all you guys online tomorrow, or I'll see you in class. Have a good day. If you guys stick around, if you have questions, feel free. Otherwise, I'll see y'all later. You guys in class, if you want to go pick up your packets now. Oh, wait, did you guys already go? Okay, yeah, you guys can go. So if you want to head over to the library, remember when you walk in, right to the right, okay? When is the last day to, is she still there? Last day to pick up. There is no last day to pick up, Stephanie. You can pick them up whenever. So pick them up when you're available. If you can get it today, great. If you can't get it today, get it some point soon. They're going to be there the whole quarter. So I'm not going to like get rid of
I have like a really personal question to ask you. Of course, you don't have to answer.
It's not about my wife again, is it?
It's not about your wife. I don't know if you think I would think for your wife. I saw her one time.
All right, no problem.
I was going to my friend's house.
Wait. Hold on. Can I mute this first? Zoom user, you're still there. Who are you? You never told me your name. I don't know who to take attendance for. Please tell me who you are. Or I'm guessing you logged in and forgot. Forgot you were here. Now I'm sad because I feel lonely. I'm just kidding. Going once, going twice. Who are you? 3, 2, 1. All right, have a good day. Got to close it up.